already watched the accompanying videos that I have included with the Google Classroom, the links, okay, to different amazing kinds of projectiles. You had a trebuchet, you had a slingshot, and then finally you had a bow and arrow, each person a master in his or her own craft. Now, if you have watched those, then you know that all of those fit the definition of projectiles. Because remember, class, what is a projectile? It is
a flying object that doesn't go ahead.
A flying object that is given an emission velocity and something is like
very good. It is a flying object that's given some push at the beginning, but then after that, nobody's touching it, nobody's pushing it, okay, other than external forces. Okay, cool. So then, if you use the equations, they can tell you a lot of things. They can tell you where a projectile will land, where it will travel. They can even tell you how fast the projectile was going and the time. It just depends what you have, what information do you have on this projectile. So let's go ahead and consider the following problem. Let's say that we have a bow and arrow. And so you have somebody, anybody here like shooting bow and arrow?
Sir, archery season starts earlier than normal day season.
Oh yeah? And how many years have you been shooting?
Archery, not very long.
Not very long? How about you, Karime? How many years have you been shooting? A lot. Okay, good. We'll have to have an archery competition sometime. Okay, so it's a little different. All right, so let's pretend then that we have an arrow. The great thing about physics equations is that they will tell you exactly where the arrow is going to be, where it's going to land, and at what time. That's why in your project, I am asking you guys to find me the speeds. Okay? And let's go ahead and pretend that we know a lot of things about this particular object. Let's say that this arrow traveled, let's call it about 100 meters. From here to here. And let's say that this arrow took about, call it about, no, that's too much. So let's say 6.5 seconds to land. All right. It was just hiccups. All right. So then let's find out a couple more things about this arrow.